Okay, so target 7, unit 9, we're going to solve 9 right triangles using the law of sines. So right now, I just want to discuss once more when we had right triangles and we used trig to solve. Um, so let's say we have this right triangle, 90-degree angle here, that we have 10 here, and let's say this down here is 35 degrees. Up to this point, how have we solved for the triangle? Well, we've used our trig ratios. If I want to find this side right here, it's opposite of 35, and then 10 is the hypotenuse, so we're going to use the sine ratio. Sine of 35 equals opposite over hypotenuse, and this is what you would do, and this is what you learned previous to target 7. So we're going to cross multiply. X times 1 is x, and then you have, and then you have 10 times the sine of 35. So now we get out your calculator. It's really important that you make sure you type this stuff in correctly. And when you do that, you should get 5.736 if we round it. So x over here, 5.736. Okay, so that's one way we can find that side, but there is another way. We also have the law of sines and law of cosines. Now, for law of sines, that formula is here. You can use this. A is basically a side. So A, B, and lowercase a, B, and C is a side of the triangle. So let me draw a triangle here so you kind of understand what I'm talking about. Here, A, B, C. Those are the vertices. And then if this is angle A, then side A is down here, and it's going to be a lowercase a. If this is angle B, then side B is opposite of that, and then finally side C is over here. So A, B, and C here on the lowercase a, B, and C, that's the lengths of the sides of a triangle. And then this A, this B, and this C, those are the angles. Okay, we're taking the sine of those. So let me explain what all this means. Basically, you could take side A and divide by the sine of A, and that should equal side B divided by the sine of B. So you can basically use this proportion to solve other parts. So keep this in mind. You have this formula. You also can use you can put the sine of the angles on top. That would also work. So let's go back to that problem that we were just working on. Here, we're going to find x using law of sines. So I'm going to do the sine. Well, first off, if we're going to do law of sines, we have to have a side and an angle opposite of each other that we know. Okay, so let me real quick go back here. If you look at the formula, and we just focus on maybe these two ratios, within those two ratios we have 1, 2, 3, 4 things we don't know. So in order to use law of sines, you're going to use 2 of the ratios in the proportion, and you have to know 3 of the 4 unknowns to solve for the 4th unknown. So basically, one of these ratios must be totally complete. Like you have to make sure you have, say, angle A and side A, and then basically one of the other 2 variables. Okay, so you have to have a side and angle opposite of each other in order to set up law of sines. So we have the sine of. Let's see. Do we have an angle and a side opposite of each other? We have 10, and we have this right angle here. So I could do sine of 90 over 10 equals, now I have to do sine of another angle, that will be 35, over its opposite side, x. Okay, now you need to focus in on this video. There's going to be a lot to it, but if you focus, pause it if you need to, but you got to make sure you're following along, because this will get easier, but you just haven't seen it before, okay? So make sure you understand how I set this up. I did the sine of 90, and it's opposite of 10, so over 10, and that has to equal the sine of 35 over x. Now I'm going to cross multiply. So we're going to take 10 times the sine of 35, and once we do that, we will divide by the sine of 90. So we're going to type that in our calculator. And if we do that, x equals 5.736. Okay, and you have got to use your calculator as you go through this to make sure you're getting the same answer I'm getting, because I'm just writing up numbers. But as you watch the video, make sure you are typing everything in so you know how to get there. So my point is this: with this problem, we could have. There's other ways to actually solve for missing parts to the to triangles. We can actually do, whoops, we can do law of sines. And the reason we have law of sines is because not every triangle is a right triangle. All right, so when to use law of sines? Well, if we have a triangle, let's start off with, say we have this triangle right here. And let's say this is 30 degrees, and let's say this is 40 degrees here. And then we know this side is 5. That is angle, angle, side, because the side that we know is not in between the two angles. So that's why that's angle, angle, side. And if you have that, you can do law of sines because you have an angle and a side opposite of each other. So you can, if you want to set this up, we're not going to solve it, but you could do sine of 30 over 5 equals the sine of 40 over x, and x would be right here. Okay? Now, that's because, again, we can use law of sines if we have an angle and a side opposite of each other. All right, now, another situation we can use law of sines is angle, side, angle. So that means basically we know two angles. Let's say this is 30 and 40, and then we know the side in between those two angles. Let's say that's 7. Well, you might think when you look at this triangle, you might realize the angle, we don't have an angle and a side opposite of each other that we know. I mean, we have 30, but we don't know this side. Okay, we have 40, but we don't know this side. And we do know 7, but we don't know the angle opposite of 7. So how can we still use law of sines? Well, because we know two angles, we can find the third angle. 30 and 40 is 70. That would make this angle up here 110. And now we do have an angle and a side opposite of each other. So we can set up law of sines. Sine of 110 over 7 equals the sine of 30 over x. And we can let this be x, because that's opposite of 30. And then you could do sine of 40 over y. And we might as well let this be y right here. And we could solve all, basically we can solve for all three parts of the triangle. Okay, so now we're actually going to put this into practice. All right, so first question, can we use the law of sines? And you got to look, do I have an angle and a side that I know that are opposite of each other? We have that here and here. So we're going to do the sine of 70 over 12, and that has to equal the sine of, we have an 80-degree angle, and that's going to be over b. Now, let's make an estimate. 12 is across from 70. B is across from 80. So should that be more than 12 or less than 12? And since 80 is bigger than 70, then B is going to be bigger than 12. So just keep that in mind. All right. So B should be bigger than 12. Let's solve. Use your calculator. Do the sine of 80. And then you're going to times that by 12. And then you will ultimately divide by the sine of 70. So sine of 80 times 12 divided by the sine of 70 should give us B. So I'm going to type it in my calculator. You need to do the same thing. And you should get 12.576, which is bigger than this 12 right here. Okay. All right, so now let's find the other parts. We can find angle C. 80 and 70 added together is 150. And 180 minus 150 is 30, so angle C is 30. And now we can find side C by doing law of sines. So we're going to do the sine of 30 over C equals, and I'm going to pick 70 and 12 again just because 12 is exactly the length of A, and we did kind of round that decimal. So sine of 70 over 12. and we'll cross multiply again. So I'll take sine of 30, or take 12 times the sine of 30. So we multiply these two together, and then divide by the sine of 70. 12 times the sine of 30, and then divide by the sine of 70. And I'm getting 6.385. So 6.385. And notice 6 is less than 12 here and here, and 6.8 or 6.385 is opposite of 30 degrees, the smallest angle. So that's how we use law of sines. I mean, it's if it's just you're still setting up ratios and going through the steps to solve. Okay. Okay, let's take a look at this one. So label the vertices A, B, C, and then what do we know for angle A? We don't know anything. Angle B is 30. Angle C is 115. And then side A is 30. And I know the side A is 30 because side A has to be, well, side A has to be across from angle A. Okay, now first question, can we do law of sines? Do we have an angle and a side opposite of each other? And in this case, we don't right now, but we can find the missing angle up here and subtract 30 and 115 from 180. So 30 and 115 is 145. Subtract that from 180 and you get 35. So now we will do law of sines. Sine of 35 over 30 equals the sine of 30 over, so if I'm going to do 30, I'm doing it over this side, which would be our lowercase b. This length of 30 is opposite of 35, and that angle is bigger than this 30 right here, so this should be less than 30. Less than 30. We'll see how much less than 30. Okay, so I'm going to do 30 times the sine of 30 and divide by the sine of 35. And I'm getting 26.15. So 26.152. Okay? And now we only have one more piece to find. That's C right here. So I'm going to do, let's see, the sine of 115 over C equals the sine of 35 over 30. And cross multiply. And C should be bigger than 30 and 46, because it's across from 115. So let's see. And you are plugging in your calculator right now, hopefully. And I hope you got 47.403. That'd be the length of C. Okay, now we're going to discuss the ambiguous case, and basically with this, there could be triangles where you're given information, but it's not possible to form a triangle based off of that. There are some situations where you're given information where it's possible to form two triangles off of that, and then there's times when you can only form one triangle, which is the stuff we've been doing right now. So what would that look like if it was no triangles? Let's say you had something like this. Let's say this was 2, this was 50 degrees, and this was 10. Okay, let's just say that was the case. Could we, looks like a triangle, right? Yeah, well, this is possible. You could form a triangle, of course. So let's see. Could we figure out what this angle is right here? So I would do the sine of 50 over 2, and that equals the sine of x over 10, right? So let's cross multiply. You're going to do go ahead and do the 10 times the sine of 50. And you get 7.6. So 10 times the sine of 50 is 7.6, and that equals 2 times the sine of x. And now divide by the sine of, or divide by 2, and we get 3.83 equals the sine of x. And now with 3.83, we're going to sine inverse. do the sine inverse of 3.83. Now, it's sine inverse because we're finding the angle. And if you do the sine inverse, what are you getting? You are getting probably domain error, or something. It's basically saying it's not working. So a couple things we know if that's the case. This cannot be a triangle here, and I'll show you why in just a minute. Well, no, I'll show you why now. And then we'll talk about the unit circle. So let's talk about why this can't be a triangle. If you see the information given, 3 of those pieces are fixed. Okay, so I'm going to create a 50-degree angle the best I can right here. So I'm going to do the best I can, see if I can get close to 50-degree angle. We have a line here. That's probably about 50 degrees, right? Now let's say this is 10. Now I don't know how far this side extends out. I mean, we don't know anything about the bottom side yet. So it could be this short. It could be this long. I mean, we don't know. We just know it extends in this direction. It can't go down like this because it's supposed to be a 50-degree angle in that location, okay? So maybe, we don't know how far this is going to go, but we just know it's going to be out in this direction. We do know this is 10 here, okay? And then we have the 2 right next to the 10, right? So the 2, I mean, obviously 2 compared to 10 is much shorter. So would that look like 2 to you? That's, wouldn't you say 5 of these makes up 10 right there? So what do you see? If this is 2, that's 10, 50 degrees. You can't, it won't reach. It won't reach down here. It's too far. So this can't be a triangle. It's impossible. And that's why it doesn't work. Now the other reason it doesn't work is you can never have, if you have the sine of an angle equals, I think we got like 3.6 or something. Sine of any angle, if you remember it's opposite over hypotenuse, well, the opposite side has to be less than the hypotenuse. The hypotenuse is always the biggest side. So if the opposite is less than the hypotenuse, that means this fraction has to be less than 1 because you got a smaller number on top. So the sine or cosine of any number cannot be more than 1. So you should have known right away without typing it in your calculator that it wasn't going to work. But here's one more way you can do it. We're going to talk about the unit circle. You really need to have your calculator out ready to go to type in stuff to make sure you know what I'm talking about. So here we have the unit circle. Now what does that mean? Well, let's say I create an x and y axis. So there's an x and y axis. So there's 1, there's 2. Giant x and y axis. We're looking, okay, so we're looking at it kind of microscopically, looking at it. This is 1, 0 here. This is 2, 0, and whatever. Up here is 0, 1. This is -1, 0. And here we have 0, -1. So we have, really, I want to focus on this order pair, this order pair. That's a part of the unit circle, okay? And the radius is always going to be 1. Now, we're going to form angles around the unit circle. We always have to start right here. Now again, the unit circle, this is not something you have to know. We are basically talking about big picture stuff so that the law of sines makes more sense. So make sure you bear with me here as we finish up this video. So whenever we create angles in the unit circle, we're going to form a line right here. I keep shading. Oh, there it is. Right there. And then we're going to go up. So let's say we go up here to, maybe this is 35 degrees. Okay, does that look like a 35-degree angle? I think it's pretty close. So I want to find out what this ordered pair is right here. Well, what I need to do is make sure we understand that the sine of any angle on the unit circle is the y coordinate, and cosine of any angle is the x coordinate. So why don't you type in the sine of 35? And if you've done that, you should get 0.57. Well, that would be the y coordinate. So 0.57. If you look here, it's a little bit, is that at about 0.57, a little more than half. Remember, this is 1 up here. So 0.57 right there, this is a little bit more than half. That should make sense, right? Okay, now, we're going to do the cosine of 35 degrees. Remember, that's the x coordinate. So cosine of 35 degrees is 0.82 if we round it. So this is 0.82. Well, that would be again, that's the x coordinate. If you look 0.82, does this look like It's a lot closer to 1 than the y-coordinate, so that's 0.82. So that's what this does. If we want to find, let's see, let me back up to the beginning. Let's say I want to find this angle right here. Go straight up. That's a 90-degree angle. Then we're talking about this point. Well, remember the sine is the y-coordinate. So type in the sine of 90, and this is huge right here. Sine of 90 is 1, and that is the y-coordinate up here. You see with 1. And if you do the cosine of 90, that'd be the x-coordinate. Well, if you type in the cosine of 90, you're going to get 0, which is the x-coordinate. Okay, so now, if you remember the last problem, we said we have the sine of the angle equals 3.6. So at what angle are we going to get to 3.6 on the y-axis? 3.6 is up here. So as we go around the unit circle, we're never going to get to 3.6. We can just keep going and going and going and going and going and going and going. We are never going to get up to 3.6, and that's why this is impossible. All right, so we're going to stop the video there. You can watch the next part if you'd like. I don't want to make these videos too long. Maybe take a break, kind of refresh on what you've done, and then watch the next video.